So this is the house that needs wiring. Good house, huh, by the way? Nice place. Let me read my plan and see. Come here, Raju.
Yes, sir.
Have a look. Okay. As per the plan, the first task is wiring from input supply. That is the main supply line up to the distribution box. And that's just what we'll see in this session on input supply wiring. After completing this session, you will be able to wire the input supply up to the distribution box. Friends, before we begin wiring, let us find out how many electrical appliances are needed for this house. I'll begin with the corridor. The corridor will have one light. Let's start counting the electrical points. So that's 1 here. Each bedroom will have an AC, a fan, and a tube light. That means a total of 3 electrical points per bedroom. So totally 6 for 2 bedrooms. Now the bathroom needs a tube light and a geyser. That comes to 2 points. The kitchen appliances will be an electrical stove, a grinder, a mixer, an oven, a rice cooker, an electric chimney, an exhaust fan, a tube light, and a fan. So that's a total of 9 points. Finally, the living room will need 2 fans and 2 tube lights. That's total 4 points. Friends, why do you think this exercise was necessary? That's right, to know the total number of electrical points, which will help us calculate the total capacity. So we will need a total of 22 electrical points for this house. Out of these, 6 are high load points, and these are the electrical stove, the oven, the electrical chimney, the 2 bedroom ACs, and a geyser. These 6 high load points have a capacity of 15 amps each. The remaining 16 are lights and fans, which are low load points, with a capacity of 5 amps each. Now let us calculate the load. The equipment in this house includes an electrical stove of 2000 watts, a grinder of 1200 watts, a mixer of 800 watts, an oven of 3000 watts, a rice cooker of 1000 watts, an electric chimney of 2000 watts, one exhaust fan of 1000 watts, 2 ACs of 1500 watts each, and a geyser of 3000 watts.
The total load for all the equipment comes to 17,000 watts.
Always provide additional points for appliances, equipments to be fitted in future. So total load capacity required will be 21,500 watts. That will suffice for any future expansions too. Friends, we have done quite a few calculations. Let me quickly sum up for you. This house has 22 electrical points. Of these, 16 are of 5 amperes, 6 are of 15 amperes. The total load is 21,500 watts. With this information, we are now ready to begin the input supply wiring. Step 1. Wear the personal protective equipment. Safety gloves, rubber shoes, and eyeglasses. Step 2. Find out the total number of electrical points required. We already know that the house has total 22 electrical points. Step 3. Calculate the load. We've done this, and for our house the load comes up to 21,500 watts. Step 4. Select the correct fuses and correct isolator for the load. Well, we need to select the correct fuses and the correct isolator for the load. And these are required for safety purpose during current overload and overvoltage. And since the total load is greater than 3000 watts, the input supply should be 3-phase. And therefore, we need 3 single-phase fuses and 1 3-phase isolator that acts like a circuit breaker. Step 5. Check the energy meter for the load capacity. Friends, the energy meter is always fixed by the electricity board. But for you to understand, we have fixed this replica of the energy meter. The energy meter comes with standard current ratings that are fixed by the electricity distribution company. And this 3-phase 20 amps energy meter can take a load capacity of 21,500 watts. Step 6. Mount the fuse box and the isolator cutout on the input supply board with the energy meter. Before we proceed with the demonstration, friends, I am going to bring back the block diagram. This will be our reference point. 1. Mark the area for fixing the fuse box on the input supply board. Use a drilling machine, drill holes in the marked locations to fit the fuse box on the input supply board. Using a suitable screwdriver, fix the fuse box to the input supply board with the help of screws. Similarly, mark the places for other 2 fuses and fit them on the supply board by using drill machine. Mark the area for isolator cutout panel on the input supply board in such a way that there is easy access to the components. Using a drill machine, drill holes in the marked locations to fit the isolator cutout switch panel. Fix the isolator cutout switch panel to the input supply board. Then fix the cutout switch over the panel by locking it by the lock with the panel. We have completed the mounting of the fuse box and the isolator cutoff switch. But if there is a steel or a wooden panel, we need to cut holes on the input supply board for the inlet and the outlet wires. Step 7. Connect the fuse boxes to the energy meter and the energy meter to the cutout switch. Now we need to connect the fuse boxes to the energy meter and the energy meter to the cutout switch. For that, we need to cut pieces of 2.5 square mm wire that we need to connect to the input supply board. Let us follow the phase color coding and connect all our wires. Well, I have a few cut pieces. Let me show you. Red for the R phase, yellow for the Y phase, blue for the B phase, black for neutral, and green for earthing. Are you ready to see? Come, I'll show you. Use a wire stripper to cut and strip the ends of the wire ready for the use. Step 8. Do the wiring for the input supply board. The input supply main has 5 terminals. The 3-phase terminal ends are Y and B. the black neutral terminal end, and the green terminal which has the ground wire or earthing. Similarly, the energy meter will also have the 4 input terminals and 4 output terminals. R phase input, Y phase input, B phase input, neutral input, R phase output, Y phase output, B phase output, and neutral output. Similarly, the fuse cutout will have 3 input terminals and 3 output terminals. The R phase input, the Y phase input, the B phase input. The R phase output, Y phase output, B phase output. First, connect the input supply wires from the main to the input terminals of all the fuse boxes. Start by connecting the R of the main to the first fuse box. Similarly, connect the Y and the B of the main to the input of the second and the third fuse box. Using a suitable screwdriver, tighten the wire connections. Next, connect the output terminals of the fuse box to the input terminals of the energy meter. Start by inserting the red wire into the R phase fuse output. Similarly, insert the yellow and the blue wires into the Y and the B phase fuses output. Connect the R output of the fuse box to the R input of the energy meter. Similarly, connect the Y and the B outputs of the fuse boxes to the Y and the B inputs of the energy meter. Then take the black neutral wire from the input mains and connect it to the input neutral terminals of energy meter. Finally, we connect the energy meter to the fuse cutout switch. Start by inserting the red wire into the R phase output of the energy meter. Then insert the yellow and the blue wire into the Y and B phase output terminals of energy meter. Then connect the R output of the energy meter to R input of the fuse cutout switch. Similarly, connect the Y and B outputs of the energy meter to the Y and B inputs of the fuse cutout switch.
Close the fuse box.
Well, it's time for me to leave. I'm just joking. It's time for us to leave the earthing wire of the input supply main, the neutral output of the energy meter, the RYB output of the fuse cutoff switch. We will come back to these later when we connect these to the distribution box. Check the display on the energy meter blinking. This indicates the supply is on. Well, that completes the process for input supply wiring. So friends, let us summarize the process of input supply wiring referring to a block diagram. The first step is to connect the main input supply to the fuse box. We can also pass the phase wires through the bus bars for extra safety. Then, next we have connected the fuse box to the energy meter, which in turn is connected to the fuse cutout switch. Our wiring has progressed up to this distribution box. The new task is the wiring of the distribution box, which we will see in the next session.